Before we start saving our data, we should first understand how are we going to structure our folders and files, as well as create the necessary classes. So let's start by understanding the structure. Here is an example of what a simple graph looks like. It has a grouped node, an ungrouped node, and a group. We will be separating the structure into two different parts, the editor part and the runtime part. The editor part will simply hold the graph scriptable object, which contains all the data in the graph and will be used to load the graph anytime you want. The runtime part will contain all the scriptable objects that will be necessary for the custom inspector and for the game dialogues. This of course means that updating the runtime scriptable objects won't affect the graph, as we'll be loading the data from the editor scriptable object. Therefore, I recommend updating everything through the graph. So let's see what each part of the graph will lead to. The first thing we have here is the toolbar file name. This will go towards the editor part to the graph scriptable object that we talked about early on. This scriptable object will hold the file name, the list of groups, and the list of nodes in the graph. This name will also serve as the parent folder of our runtime part. Every group and every node scriptable object will be inside of this parent folder. This is basically for organization and to know where can we find the assets, useful for the custom inspector. To help us out for our custom inspector, we'll also have an asset with this name inside of the parent folder, which will hold all the groups, grouped nodes and ungrouped nodes, as well as some useful methods later on. For our groups and nodes scriptable objects inside of this folder, we'll be separating them between different folders, the global folder and the groups folder. The global folder will hold every ungrouped node scriptable object. Although there will only be ungrouped nodes there, we will still be adding them inside of a folder named dialogues, which is what we'll be calling our nodes in the runtime part. The groups folder will hold every grouped node scriptable object as well as what group they belong to. Each group will be divided into a folder with its name, and inside of that folder there will be one scriptable object that will hold the group data, which will just be the group name, as well as a folder named dialogues that will hold every node scriptable object of that group. Here is an example of the assets already created in a project. We'll go into more detail on what each scriptable object or class needs when we are creating them. We will start by creating our editor part classes and scriptable object. It will be divided into 4 classes, one of which is a scriptable object and the other ones are normal classes. The node data, which will be a normal class, the choice data, which will also be a normal class, and the group data, which is the other normal class. For our scriptable object, we will have our graph scriptable object that uses all of the other classes. So let's start by creating our node data. To do that, first create a new folder in our editor data folder, which I'll name save. We will be adding every editor save data class here. Then inside of this new folder, create a new C# script which I'll name DSNodeSaveData. Inside, feel free to remove the default methods as well as the mono behavior inheritance. I'll make it part of the data.save subnamespace. In our node, we have a few things we want to save. The name of the node, the dialog text, the connections of the node or choices, the group it belongs to, the node or dialog type, which is either single choice or multiple choice, and where it is positioned in the graph, to make sure we position it back at the right place. So let's start by creating a public property for all of this. If you are not using Unity 2020 or above, you might just want to make them a normal public variable instead, because we are going to be using the field serialized field attribute here, which works for properties in Unity 2020 and above, without needing to create a private property variable ourselves. Every property we will be creating will be an automatic property. So type in public string and I'll name it name, and set it as an automatic property. I'm fine with naming it name here because there is no built-in name variable in this class as we aren't inheriting from anything. Then type in public string text. When that's done, create a new public list of strings to which I'll name choices. We will not initialize this list because when we start saving, we'll simply assign an initialized list into it. For our group, we'll actually be using an ID. This will make it so we don't really need to reference the group itself and can just get it through its ID. So type in public string group ID. This ID will be useful for the way we'll be saving as well. Next, we'll need our dialog type, so make sure you import the enumerations namespace above. And then type in public DSDialogueType, and I'll name it dialogType. And last but not least, we will have our node position, so type in public vector2 position. As our class stands, it won't really show in the inspector in our scriptable object. So make sure you make this class serializable by typing in the serializable attribute at the top, which needs the system namespace. Then in Unity 2020 or above, if you want to make a property show up in the inspector, you will need to type in field serialize field just before our property declaration. If you are under Unity 2020, then you could only make it show up by creating the private field yourself and assigning the serialized field to it. You can just use public variables if you prefer. Do this for every single property. Our node is almost done, but our choices won't really be strings. This is because besides the text the choice has, we also want to know what node it connects to. This will be useful when saving to know what dialog does a choice connects to. So we'll be creating a new class that will hold the choice data. So back to our SaveData editor folder, create a new C# script to which I'll name DSChoiceSaveData. In here, remove the default methods and the inheritance as well. I'll make it part of the data.save subnamespace. We'll be creating two variables, the text of the choice as well as the node the choice is connected to. So type in public string text and make it an automatic property. Then we'll want our node reference. However, we'll do it like we did for our group. We will reference it through the node ID. So type in public string node ID and make it an automatic property as well. To make this class show up in the inspector, we'll need to do the same as in our DSNodeSaveData script. So make it serializable and don't forget to import the system namespace. And then type in field serialize field in each of the properties. With the IDs being used now, we need to make sure our data has that ID in. So go back to our DSNodeSaveData script and make sure you create a new property of type string, which I'll name ID. Don't forget to swap our string in the choices list type to be DSChoiceSaveData instead. With this, we will of course need to make sure our DSGroup and our DSNode have an ID variable as well. So go to our DSNode script and create a new property of type string, which I'll name ID. We will then initialize it in our constructor by using the system GUID.newGUID method. Don't forget to call the toString method as well. This method simply automatically creates an ID for us. Of course, we need to do the same for our group, so let's add to our DSGroup and create a new ID property. Then initialize it in the group constructor. Don't forget to import the system namespace. That's done, so let's keep on creating our saved data. The one we'll be creating next is the data for our groups. So in our SaveData editor folder, create a new C# script to which I'll name DSGroupSaveData. Inside, remove the default methods and the monobehavior inheritance. I'll make it part of the data.save subnamespace. We'll be having three variables for our group: the ID, the name of the group, and its position in the graph. The ID will be useful for us when loading, as we'll be able to set it to be the ID the group had when we first created it. This is because when initializing, it initializes as a random ID, which we don't want to when we start loading our graph, as otherwise ID references will be wrong at every load. So create a new automatic property of type string to which I'll name ID. Then create a new one for the name of the group. When that's done, create one of type vector2 to which I'll name position. Of course, we need to make this serializable, so type in the serializable attribute at the top, importing the necessary namespace. And then make every property have the field serialized field attribute before their declaration. We now have our nodes, groups and choices data done. All that's left for our editor part is the class that holds all of that data. So let's create a new C# script to which I'll name DSGraphSaveData.so, as it will be a scriptable object. Feel free to remove the default methods. We won't be inheriting from monoBehavior, but from scriptable object instead, as this will be our editor asset. I'll make it part of the data.save some namespace. For our graph, what we'll need to save is quite simple. The file name, which will be the name of the graph file, the list of groups that are present in the graph, and the nodes that are present in the graph. We don't really need to care if they are grouped or ungrouped nodes here, because we'll know that through their data, as nodes have a group ID as a variable. However, we'll also have a system where we'll remove files that have a name of a node or a group that isn't used anymore. For example, if we had DialogueNode1 and DialogueNode2 as assets, but then updated the DialogueNode1 to be DialogueNode and save it, we will need to delete the old DialogueNode1 asset file and create a new one with the name of DialogueNode. We could simply update the name of the file to have the new node name, but I find it simpler to just remove it and add a new one. If you decide to update it instead, remember that you can create other nodes with the name of the old node name. So make sure you update them first before creating the node asset files. For this system, we'll simply create the current group, group nodes and ungrouped node names at every save. If they already exist, we'll simply return the loaded file instead of creating a new one and update its contents. So we'll need to have lists for the names of the groups, grouped nodes and ungrouped nodes. Then with those names, we will iterate through them and see which ones are different than the current names we have in the graph. Those that are different can simply be deleted. So we'll be having a list of old group names, a list of old ungrouped node names, and a dictionary of old group node names, in which the key will be the group name. So create a new automatic property of type string to which I'll name filename. You could go with name here if you wanted to, but because scriptable objects have a name variable with lowercase, I'll just type in a different name. Then create a new list of type DSGroupSaveData and I'll name it groups. For our nodes, create a new one of type list DSNodeSaveData. Next are our old names, so create a new list of type string and I'll name it old group names. Do the same as above, but name it old ungrouped node names instead. For our old group node names, create a new serializable dictionary and make sure that this one is a serializable dictionary and not a normal dictionary, as dictionary is not serializable, so our data will disappear. And I'll pass in string as a key, which will be the group name, and a list of strings as a value, which will be the nodes that belong to this group. I'll name it old group node names. Because this is a scriptable object, we don't need our serializable attribute. We do however need our field serialized field attribute, so type that in before each property. In here we'll actually need to initialize the groups and nodes list as well as the file name. So create a new public method to which I'll name initialize, and pass in as a parameter a string named filename. Then assign this filename parameter to our filename property. Next, initialize both our groups and nodes list. We won't be initializing the old names list here because we'll need to know the names every time we save the graph. but because we'll always call the initialize method before we start saving, having a list initialization here will make the list empty, meaning we won't have a way to compare the old names with the new names anymore. Our other two lists are fine because we'll assign new values to them without caring about the old ones. We now have all the classes our editor part needs. However, we still need to make the runtime part scripts. We will need one for the dialogues, which are our nodes, one for the groups, a data class for the choices, which will hold references to the next dialog scriptable object, and one for our container, which will hold the references for our groups, grouped and ungrouped node scriptable objects. This one will be useful when creating our custom inspector to select the starting dialogues and filter them out by grouped and ungrouped dialogues. Let's start by creating our dialog scriptable object, and to do that I'll create a new folder in our non-editor dialog system folder, to which I'll name scripts. Inside I'll add yet another folder to which I'll name scriptable objects. In that folder we'll create our C# script to which I'll name DSDialogueSO. I'll type in SO at the end of our 3 scriptable object scripts, much like we did for the graph one. Inside, feel free to remove the default methods and swap the inheritance with scriptable object. I'll make it some namespace scriptable objects. In here we'll be having a few of the variables we already have in our DSNodeSaveData, but not every single one. We'll be having the dialog name, the text, the choices and the dialog type. We don't really need the group ID here because we'll know which group they belong to from another scriptable object. And we don't really need the position either. We will however have a new boolean variable which will basically tell us if the dialog is a starting dialog. A starting dialog is simply the dialog that starts the dialog chain, so the very first dialog. We could have added an UI element to the node to decide it, but what we'll do is in my opinion simpler or better. If the node does not have an input port connection, then it is a starting dialog. So type in public string dialog name and make it an automatic property. And then public string text. For our choices, we'll be giving it a list of strings in which we'll update it in a bit when we create our choice scriptable object script. Then import the enumerations namespace above and create a new automatic property of type DSDialogueType to which I'll name dialogType. For our last property, type in public bool and I'll name it isStartingDialog. We don't need our serializable attribute here, but we do need our field serialize field, so type it in for every property. I'll also add the field text area attribute to the text property, for us to be able to see the text in multiple lines. In scriptable objects, people often just use public variables, but because I'm using Unity 2020, I've used properties, as they can be shown in the inspector with the field serialize field attribute. To set the values for the dialog scriptable object, we could update each variable one by one, but it's easier to just set them all through one call. Unfortunately, we will be initializing the assets using the createAsset method that Unity provides, so we can't really use the object initializer there. Therefore, we'll create our own initialize method that accepts all variables and sets them. So type in public void initialize and I'll pass in the following parameters: string dialog name, string text, list of strings, which I'll name choices, DSDialogueType, dialog type, and bool is starting dialog. Then simply assign the values to the corresponding properties. We now have our dialog scriptable object done, So we'll create a ChoiceData next, which won't be a scriptable object, but simply a normal class that will be used in our dialog scriptable object. So in Unity, go back one folder and create a new one, and I'll name it Data. In here, create a new C# script, to which I'll name DSDialogueChoiceData. Inside, remove the default methods and the monobehavior inheritance. I'll make it part of the data subnamespace. Then we'll be having the same variable as in our other ChoiceSaveData script, but the dialog won't be an ID here, but a reference to an actual dialog scriptable object. So type in public string text for our choice text. Then import the scriptable object's namespace, as we'll be needing it for our dialog reference. Next, create a new property of type DSDialogueSO, and I'll name it NextDialog. This is how you'll know what's the next dialog you want to show in your game dialog system. Of course, don't forget to make this class serializable, in which you'll need to import the system namespace. And as always, type in the fieldSerializedField attribute before each property. Our choice data is done, so let's swap it out at our dialog scriptable object. So go back to our DSDialogueSO script and swap the list string to be list of DSDialogueChoiceData. Make sure you import the data namespace above. We have our dialog and choice done, so let's do our group. Go back to the scriptable objects folder and create a new C# script to which I'll name DSDialogueGroupSO. Inside the script, remove the default methods and swap the inheritance to be scriptable object. I'll make it part of the scriptable object subnamespace. We'll only have one variable here, and that's the group name, so type in public string group name. I'll set it as an automatic property. Add the fieldSerializedField attribute to this property. We'll have to allow this variable to be initialized, so create a new public method to which I'll name initialize and pass in string group name as a parameter. Then set the group name property to have the value of this parameter. We have our dialogues, dialog choices, and dialog groups. All that's left now is to create a scriptable object that will hold all of our groups and dialogues in a way that will allow us to know which dialog is a grouped dialog and which one is an ungrouped dialog. This scriptable object will be used for our custom inspector to select the starting dialog. So create a new C# script to which I'll name DSDialogueContainerSO. Inside, remove the default methods and swap the inheritance to be scriptable object instead. I'll make it part of the scriptable object subnamespace. As variables, we'll be having the file name, the groups, the grouped dialogues, and the ungrouped dialogues. So create a new public string to which I'll name filename. This will be needed to load the assets in the correct path, as the parent folder has the same name as its file name. Then we'll be having the groups and the grouped dialogues in the same property. We can do that by making it a dictionary with the key of DSDialogueGroupSO and the value a list of DSDialogueSO. This makes it so that if we need the list of the groups, we simply iterate to the dictionary keys and get them. If we wanted the dialogues of a certain group, we simply get the value of a certain key. So type in public serializable dictionary of key DSDialogueGroupSO and of value list of DSDialogueSO, and I'll name it dialog groups. To make sure you are using the serializable dictionary here, as otherwise your data won't be saved, as Unity doesn't serialize normal dictionaries. Then create a new public list of DSDialogueSOs, and I'll name it ungrouped dialogues. Don't forget to add the fieldSerializedField to each one of the properties. As a last thing, we need to initialize them, so create a new public method to which I'll name initialize, and pass in string filename as a parameter. Inside, set the filename property to be filename, and initialize both the dictionary and the list. With that done, we now have both our editor part classes and our runtime part classes ready.